Balancing equations, introduction. Example 1, balance the following. Copper 2 chloride plus silver nitrate yields copper 2 nitrate plus silver chloride. This is a double replacement reaction, and you know that because you have a compound plus a compound yields a compound plus a compound. The outside goes together, the inside goes together, and if it is a positive ion, it is first in the compound, on the left and on the right. To balance equations, first write down the number of atoms for each element on both sides of the equation. Hint: if a polyatomic ion is found on both sides of the reaction, it is easier to balance the equation by keeping the polyatomic ion together. Nitrate is found on the left and nitrate is found on the right. So when we go to balance the equation, we will keep the nitrate group together. Make a chart like the following. Write down what you know. 1 copper, 2 chlorines, 1 silver, and 1 nitrate group on the left. On the right, 1 copper, 1 silver, 1 chlorine, 2 nitrates. Use coefficients in front of the compound or element to balance the equation. If I put a number here, a coefficient, it multiplies by every component of the compound. Hint: balance atoms and polyatomic ions in this order. Metals first, second nonmetals, third polyatomic ions, next to last hydrogen, last oxygen. This is the chart we created in the previous example. Start with metals. 1 copper, 1 copper, 1 silver, 1 silver, 2 chlorines, and 1 chlorine. So we need to balance chlorines. To balance chlorines, we will put a coefficient in front of the silver chloride, a 2. In doing so, it also means that we have 2 silvers. So we need to balance the silver nitrate on the left. We will put a coefficient 2 here, which will balance both the silvers and the nitrates, and it's balanced. Example 2, balance the following. Aluminum plus nickel 2 bromide yields aluminum bromide plus nickel. This is a single replacement reaction, and you can tell that because aluminum, an element, plus a compound, nickel 2 bromide, yields nickel, an element, plus aluminum bromide, a compound. Aluminum is more active than nickel. Aluminum replaces nickel in the compound. To balance equations, first write down the number of atoms for each element on both sides of the equation. Hint: if a polyatomic ion is found on both sides of the reaction, it is easier to balance the equation by keeping the polyatomic ion together. You have 1 aluminum, 1 nickel, and 2 bromines on the left. 1 aluminum, 1 nickel, and 3 bromines on the right. You have a 2-3 situation. When you have a 2-3 situation, you go to the least common multiple of 2 and 3, which is 6. So we will find 6 bromines here and 6 bromines here to balance the equation. Use coefficients in front of the compound or element to balance the equation. Hint: balance atoms and polyatomic ions in this order. Metals, nonmetals, polyatomic ions, hydrogen next to last, oxygen last. This is the chart from the previous slide. I have a 2 and a 3 situation, so I know that I'm going to the least common multiple of 2 and 3, which is 6. Starting with metals, My aluminum is balanced, my nickel is balanced. Moving to nonmetals, I need to multiply by 3 to get 6 on the left side. So I will put a 3 in front of the nickel 2 bromide. And that means I now have 3 nickels, and 3 times 2 is 6 bromines. Now I need to fix the bromines on the right. I have a 3, I will multiply the aluminum bromide by 2. And when I do so, that means I'm going to get 2 aluminums, and 2 times 3 is 6 bromines. I have 6 bromines on both sides, so my bromines are balanced. Let's balance the nickel. I have 3 on the left and 1 on the right. If I put a 3 in front of the nickel on the right, my nickel will be balanced. Now I need to balance my aluminums. I put a 2 in front of the aluminum on the left, and I have 2 aluminums on both sides of the equation, 3 nickels on both sides of the equation, and 6 bromines on both sides of the equation.